Hello, some people reached out I should make a video on how to plot in Python. That's what I'm going to do in this particular video. And so I'll be showing you how to make basic plots in Python, but also to make customized plots, how to label the axes, like use several of the features of the Matplotlib package, how to make scatter plot, for instance, histogram, pie chart, and a lot of plots. So this is like a tutorial dedicated to plotting in Python. And so let's go straight into it. Let's start with line plot. Of course, before you plot, you need data, and we'll be using NumPy to generate data. And so we import the two packages that we're using for this tutorial, and that would be NumPy and Matplotlib. Matplotlib is a package we're using for the plotting, which is the standard package we use in plotting in Python. And so let's import stuff. We just import NumPy as np, which is the customary way. You've already seen it in some of my videos already. And then let's import the plotting package, which is called Matplotlib .pyplot as plt. And so yeah, usually people call it plt just for short, but it's a pyplot in Matplotlib that we'll be using. So if we run these two, now we have it in memory. And so let's generate data. Let's say our x is equal to this. The data will be plotting on x-axis. Let's just create data using NumPy. Let's use the NumPy linspace. With the linspace, you usually use this to like create linearly spaced data. And so let's say our data should go from 0 to maybe let's go to 30, and it should have a total of 100 points. And so this is your first point, and this is your last point, and this is the number of points you want. So it will linearly space these 100 points between 0 and 29. Usually you do -1, but sorry, up to 30, not 29. So with the NP range, you have it less than, but with this one it goes to that point. And so yeah, it doesn't matter by itself, which is great. And let's create a y. Our y would be sine curve, and so let's use the NumPy sine, and then pass in the values of our x. So we just compute this on the values of x. Great. Now if we run these two, we have data now. So if we check our x, there will be some values here, and if we also check our y, there will be values right there. Great. And so now let's do the plotting. And so for the plotting, let's call this section the basic plot, basic line plot, because this is a line plot, so just a linear. Okay, so we start usually by calling the figure. Like in MATLAB, you do something like figure. Here you have to do plt because this is a method in the plt, and so you do plt.figure, and then you do parentheses. Here you could decide to pass a lot of stuff. We'll be customizing stuff in a minute. And then we'll do the plot. So again, it's be plot. So it's in plt, there's a plot command that you just have to provide it the x, what you want to show in the x-axis and what you want to show in the y-axis, and that's it. For the basic line, let's not customize the line type and nothing in this particular one. And then you could, but with this too, you could just plot it now. It will show you the plot. This is the plot. This is how the plot looks like. But to like silence this text that's showing here, you could either put a handle here that way, or so that will go away. Or if you don't want to do this, then you could do plt.show, and that will like silence that too. So for example, if I remove that path, you wouldn't see it again, so it's done properly. Cool. Let me just zoom out a bit so that you're able to see that. And if you want to reduce this particular figure size, there's what is called fixed size. We'll be customizing stuff just in a bit, so I don't want to bother you now. But yeah, there are ways to like reduce this particular one. You just have to pass in something like fixed size, and then you could provide the size of the figure as as a tuple. And so for example, you could say let it be 5, or let's just make this one to be 10, and since we want to make it so, let's make it 8, and then make this one to be 4. So this would be like a long one. You could even like reduce this to like 3, and maybe make this one to be 10 so that you have like a very tiny plot that will show in this particular video. Great. And so that's how you manipulate that. You could do a bunch of stuff. You could like add labels to the x and the y axis by just doing plt.xlabel, and then you just do parentheses and then you pass string of what you want to show in the x-axis. In this case it's just x, so maybe that's a distance, and so let's assume that was a distance x and that was in meters. You could do it that way. Let's do the same thing for the y-axis. I will just copy that and paste, and for the y it needs to be y label. You guessed right if you have already guessed that. And the values on our y, since it's the sign, let's just say our function, let's just say it's a function, okay, and that's the function of x. Okay, and so if we run that, then we'll see these values, and these values on the x-axis being labeled by this particular marker. Great. Now we'll have our line, and then we'll have this. So this is how you make your first basic. You could also add grid lines. Let's just add grid lines in the first one before we even go to the next one. So you could do plt.grid, and in the plt.grid you just run that, then that will like add grid to all the ticks, and so it's easier to read the data, so you know exactly where this point corresponds to without like doing a lot of sketching compared to like what we had before. You could also like add legend. You could also add titles, and so to add title to this particular plot you just have to do plt.title, and in the title you just have to do another string and then give it the name of this one. Let's just call it a basic line plot, and if we run that, then we'll see that title shows up there. And yeah, I think this is good to go for the first one. If you want to change the color of this line, you just have to come to your plotting command, and you could do something like this. There's a shorthand, say red line. Let's just replace with red line, so that's red and a line. You could make this red dashed line by doing 2 dash dash, or you could make red dotted line dot dash line to be like that, this continuous line, or you could just make it to be a red dots, and so it would just be red dots, or you could make it even to be cycles or even squares and stars, so you could make it to be stars or squares. And so that's the shorthand, but you could also specify like the color itself. And so if you don't want to use the shorthand, then you could do something like maybe color is equal to, let's provide, and you could type in the red, for example, and the line style, we could provide that again, maybe a dash line. And if you run that, it will do the same thing as what we had before. So it was a combination of this that we are doing before. And we could decide to add a label to this particular plot, and for the label we could give it to be maybe line plot, for example, because it's a line plot. And to show this, if you run this, the label wouldn't show up on this particular plot, but to show it, you just have to do a legend. So you could do plt.legend, which is a key if you're in geography, a legend, and automatically it will catch this and drop it there. And so we'll have it here, showing here. Yes, that. Another thing that I'll show you probably before moving forward here is that you could also do increase the font of this. And to increase the fonts in any of this one that has text, you just have to do font size is equal to, maybe give it like 28. That's a big font. We could copy it and paste it in the other ones, and yeah, 28. And so this becomes so big now. You could reduce it to 15 if you want, but yeah, I could also do it for the legend if you want. But yeah, so that's how to make a basic plot in Python. Now let's move on to the next one, which I wanted to dedicate that one to like customizing plot, but I've already like done a bunch of the customization here. Maybe what I could just add here to like make it up is a marker. We could add a marker, and so we could add a marker, which is like a plotting symbol basically. And for the marker, let's just maybe give it like a star, and so this will plot because we added a line here and then a star, so it added like that. And of course you could make that to be like a continuous line. You could also increase this line size by just using the line width command that I made lines big and small. So that's part of the customization. So let's just add that. So we just have to do something like line width is equal to maybe 8, and if we run that, this becomes so big. You could even make it tiny if you want, for example 0.8, and that becomes so tiny. And so those are the commands. This is how you make line plot in Matplotlib. I hope you're already enjoying the video. If you're enjoying the video already, please hit the like button and subscribe if you haven't subscribed yet. But also you could also help share the video to someone that also needs to learn Python. The more you engage on this video, that's how you tend to support my channel to grow. Great, so let's go into making subplots. So there are instances where you want to make plots side by side, maybe to compare data, or you want to like maximize space, or yeah, there could be a bunch of reasons why you want to make another figure by the side of another figure. So, or you want to plot different data that are like on different axes, then yeah, you may need a subplot. And so now let me show you how to do subplot in Python. And so yeah, to do subplot, I mean zoom out a bit. To do subplot, again you start the same way with a figure, but let's catch a handle called fig, and let's make some axis called axis. You could write X, people use X, but I like writing it clean so that it's easier to understand. And so to make subplot, you just have to do plt instead of figure. Now we'll do plt does subplots. Subplots. It's not subplot, there's an S because it's more than one plot. And then you just provide the number of subplots you want to make. In this case I want to make 2, so a 4 panel plot, so it's 2 by 2. And we could also provide the figure size, usually, which I've already explained the other one. So figure size is equal to the size of the figure. In this case, let's just give it a 10,6. And the first one is for the x-axis, the second one is for the y-axis. And so this is like a 2 by 2 grid. And once you have that, then on the first plot, or the first subplot in the first panel, that will be our axis. And then we just have to tell it the position. The position is on 0, 0. Remember, Python counts from 0, 0, even though we're requesting for up to 2. Okay, and on this particular axis, so we're just catching this axis and we want to use it now. On this particular axis, we want to use the command called plot. And for the plot, we want to plot x in the x-axis, which we did already. And instead of in the y-axis, let's just plot our y, which was the sign of x, and let's give this particular one to be a red line. Cool. Maybe let's give it a title too, and so we could just copy that part of the code. Again, any manipulations you're doing on this first panel, you just have to use this axis to get all of it. So we'll do title. Usually, since it's a subplot, you have to do something like set title, and in the set title we give it a name that you want. This is a sign of x, sign of x. Just remove that so that we don't confuse people. Okay, and so that's the first one. We already have something on the first one. Let's just copy this and paste it down here and do the second one. So you could do 0, 1 to go to the next plot, and for the next plot, instead of y, let's do something like np the tan of x. So we're plotting the tan of x on this next axis, and this will jump to a tan of x. Again, we'll copy this and plot the next panel. Maybe let's do the 1, 1 or 1, 0. Usually 1, 0 or 1, 1, whatever you want. Whatever you want to go first. Let's do 1, 0. And for this one, let's plot a cos. So a cos of x, and so this needs to also change to cos. And then let's do the 1, 1, which will be the last panel. And 1, 1, which is like the last position, the last corner. And for this particular one, what should you use? Let's just use a negative y. So that's a negative of the sign, or maybe twice negative y, whatever. Okay, and so this is like negative sign, negative sign. And so yeah, so that's how you do it. And to make the figures tight, you could just do something like PLT the tight layout, and just make sure that everything is like within the layout, so that sort of like don't go over the window, especially when you want to like grab the figure and save it. You want everything to be contained within the layout, so you do PLT the layout. And maybe let's just do the PLT the show, even though it's not important. Let's just run that now, and this makes the plot. Again, we had red in everything, so let's change that to black. Black is the short K, blue is B, and let's make this one to be magenta or purple. If you run that, then we have the 3 plots or the 4 plots. So this is how you make subpanners. There's the negatives of the sign, and this is like it's just the opposite. So it started this way rather than the other way. This is how the time function looks like, and this is the cost. And of course, you could add the axes, like the labels to the axis, which is I've already shown in the previous one. And so I wouldn't repeat that here again. And so the video is already getting long. We're getting close to 20 minutes, which I wanted to target. Now I will show you how to make a scatter plot, but instead of like typing, I will just paste the code here and explain it, since I already have it somewhere. And so to make a scatter plot, all you have to do is to generate data first, of course, or maybe you may already have your data. In this case, I'm using a random function, and so in the numpy random, there is what is called rand. And this case, we want to generate 50 random value, and we're scaling it by 10. So we just generate those 50 random values, we'll scale it by 10. Let's generate another random values for our y and see scale it by 10, which is scale it by 20 or whatever you want. It doesn't have to be 10. And then we generate like another one that we call sizes, again by 50. I'll scale this one by 300, and then we could do random for the colors, just like have several colors. Okay, I have that, which is what we'll be plotting on as this color, the scatter, to show like this color, the color basically. And so to do scatter plot, you just have to do plt.scatter. Remember to do your figure, so you have to do plt.figure. So that starts on plot on the previous figures above. So you're just calling this figure again, and then you do plt.scatter. You provide what you want to show on the x-axis, what you have on the y-axis. You provide your sizes. Your sizes is that it's 50, but it's random, so it's changing. It could be a single value. You could just provide a 5 here, that will work. And then you do a C, which is the color. The color is the values you want to plot on that particular axis. Think of it like the elevation or like the points that you want to show in color. And so in this case, we'll have these random values here. It could be your data, it could be elevation. For example, if you have like latitude, longitude, and you want to know the elevation of a hill, then that will be the data. And then you give it a color map. Maybe let's do a jet. And then the transparency, in this case 1 is the full. We're doing it by 70% transparent, and the edge colors of this particular sizes, of the plot, we'll give it that particular stuff, black as a color. And then we'll call it color bar. Color bar allows you to see the colors. So these colors, the values will be displayed here, and you could give it whatever value you want, and then you do your x and y axis, these are the levers, and then the title, and then you do show. If you run this particular one, well, I'll have this very beautiful scatter plot. Let's move up ahead to do a histogram. I also have the code here, and so I'll just paste it so I don't waste too much of your time. Again, to have these sizes the same, you just have to change the size to be a uniform number, and that will give like a single value, of single size of markers. And again, let's generate data here for histogram. We just generate our 1D data of 1000 points randomly distributed. We'll just do our figure. Let's do our plt.figure, and here we'll have our hist is the histogram basically. So you do a hist of your data, and then provide a number of bins you want, which is like how many bins you want your data to be contained in. In this case, we provide 30, and then you give the color they want. We want to do those bars to be sky blue, and then we give the edge color for those bars, and then you give your axis label, in this case value, and then, or you could call it bin, whatever, or value or bin, whatever, frequency, and then you give it a title, and then you show. That's all. So if you run that, that makes your histogram. So that's how you plot histogram in Python. And that's the code. The code again will be available on my GitHub place. If you need it, look for it on my GitHub, and I'll try to put the link to my GitHub in the description of this particular video. We're already at the 20-minute mark, but maybe I have to push it forward a bit just to cover more ground. Let's do a bar chart. And so if you want to do a bar chart, this is how you do your bar chart. You just create your categories. In this case, create categories with a list between 1 to that, between A to D, and we have our values. This is what we show in our X, and this is what we show in our Y. And if we do a PLT the figure, and if we run this, then this will make a bar plot. So that's how you make your bar plot. Again, the command is plt.bar, and then just provide the category, what you want to show in X-axis, what you want to show in the Y-axis, and then you could give the colors as you want, and the rest is everything that I've already explained before. Now, before we end the video, let's do a pie chart. And to do a pie chart, all you have to do is to use this command plt.py. Again, we generated data here. I wouldn't go over that. You're already familiar with generating data. And then we just have to always call your figure, plt.figure. You could customize it as much as you want. Plt.figure. Sorry, I can't type. And if do the title and then the show, we just provide in the sizes and the label, just the sizes that we need basically. And if we run that, then voila, here we'll have our pie chart. There's a percentage distribution of the different fruits. And one more last thing is to how to save your figures. So after making all these figures, sometimes we want to save them. Of course, one shortcut is just to do a screenshot. On Mac, you could do your command Control 4, for example, and then it could give you this, and you could just screenshot. And then you have your figures there. But there is a professional way of doing it, and that's how you do it. This is how you do it basically. And so you have your plot already. If you want to save, you just have to do this particular command called plt.savefig, and then you just give the name of the figure, or it could be a path to where you want to save the figure. In this case, maybe my data and my plot, and then you could give it like a resolution, and then you just save. So if we save this, if we run this, that will save the figure. So that's how you do that. I'll end the video now, and I will see you in my next video. So that will be saved. That's a crazy data. Bye bye. See you in my next video.